Let's learn about something new. In this video, we're going to talk about relations. What is a relation? Well, in English, it's a very general term and it means a lot of things. But because we're in the math world, we'll be very serious about it. Let's talk about it using some examples. Let me present you some sets. Here's set A and here's set B. Now I'm going to write down the elements of these two sets. Set A has a horse, a cockroach, a unicorn, an eagle, a frog, a zebra, a dragon, a butterfly, a bird, and a fish. Okay, so these are some creatures that you can see that they are part of set A. What we have in set B is a land, water, air, and mind. We have 4 elements: land, water, air, and mind, because why not? And now let's relate set A to set B. We can do this by saying that the horse lives on land. Zebra also lives on land. Frog lives on land and water. Fishes are in water. Butterfly, air. Another bird, air. Another bird, air. Cockroaches also land. A unicorn and dragon. Okay, they don't live anywhere because they're not real. So they live in our minds. Why not? Okay, so what do we have here? We have elements from set A connected to elements of set B. These are all ordered pairs. We can say that this pair has the first element horse and the second element as land. And if we combine all of these ordered pairs, all the arrows that we have, each of them is an ordered pair. If we combine all of them and put them in a set, that set is called a relation. That is a relation between the set A and set B, or from set A to B. But what if we didn't stop at that? What if we didn't stop at just these arrows? What if we connected all possible combinations and made all possible ordered pairs? What if we had more arrows? Horse lives in water, horse lives in air, mind, and then bird has land, water, air, and mind, and then we kept going. We connected all elements of set A to all elements of set B. And if we combine all of that and then put that in a set, what would have that set called? That set would have called the Cartesian product of set A and B. That would be A times B. Because Cartesian products have all possible combinations. So that means a relation is a subset of a Cartesian product. That's the simplest definition that I could find. A relation is a subset of a Cartesian product. That's it. And these elements, well, they're related to each other. This is what we mean as a relation in the math world. Now let's talk about a few terms that would come in handy. We have a much simpler example with a lot less things going on the screen. Okay. We have two sets A and B and we have these elements. Some of the elements of set A are related to some of the elements of set B. All of them are not participating. And this is where the fun begins. Let's look at the elements that are participating. We have the horse, the zebra, the frog, and the fish. These 4 from set A that are related to some element of set B, they're called the domain. The domain is the set of all first elements in the relation. There are a lot of elements in set A. We have the unicorn and the dragon as well, but we're not going to take them. We're only going to talk about the elements that are in the relation. So that's the definition of domain. And what about set B? We have land and water. These 2 are related. Air is not related in this example. These 2 will be part of something that we call range. So range is the set of all second elements in the relation. Why first and why second? Because we're having the relation from set A to set B. So elements in set A are called the first elements and elements of set B are called the second elements. And the word range sometimes get confused with another word, and I'm going to put that down. It's called codomain. This one has a very specific definition. It's a very simple definition. Codomain is simply the entire set B. Whatever you have in set B, that's part of codomain. So codomain is land, water, and air. It doesn't matter if you're related or not. If you're part of set B, you're part of codomain. So let's recap. The domain is set of all first elements in the relation. So all the things from set A that are related to something in set B, they'll be part of domain. And all the things that are related in set B, they'll be part of range. Okay. There are 2 more jargons that are thrown in this topic, and let's take them up as well. This is an ordered pair. We have the horse and we have the land. Sometimes this land is called the image of this element horse. We say that land is the image of horse. Don't ask me why. And we go the other way around as well. The horse is called the pre-image of land. So we'll have pre-images from set A and we'll have images from set B. This is how things work. All right. Now this is a very visual way of looking at the relation between set A and set B. There are other ways to do the same. And you might recall that we've done this in sets as well. One of them is called the roster method and the other one is called, yes, set builder method. The roster method is the answer method and set builder method is the question method. So let's write this relation down in the roster form. We'll need some brackets, curly brackets, and then we'll have these 5 elements. Why 5? Because we have these 5 ordered pairs. 1, 2, 3, 4, and 5. The first one is horse and land. Second one is zebra and land. And then we have frog and land, and then frog and water, and then fish and water. Okay. This covers up our relation. And the way to write this in the set builder method is like this. We have R, that's the set of all X and Y, these are ordered pairs, such that, and after such that you'll have a condition. Just like we have for other sets, we'll have it for relation as well. The condition is Y is where X lives. And you have X belongs from A and Y belongs from B, and you close the bracket. That's how you write it in the set builder method. We'll be taking care of numericals in the next few videos. I hope by now conceptually things are making sense. These are very keywords: domain, range, and codomain. A good understanding of all of them will go a very long way.